Okay, so this is about dimensional analysis. So all of these problems, when you're working them out, there's a whole lot of numbers, and trying to manipulate the numbers, it gets overwhelming. If you're worried about the numbers and trying to make the numbers do what you want them to do, then you're not going to do well with these problems. The whole point of these problems, is for you to understand the units, for you to be able to manipulate the units. The numbers will follow in line as long as you follow the right procedure. The numbers will work out, and it's fine. So that you got to make the units do what you want them to do. And this is an essential skill for anybody in the science-related field, a medical-related field, because you're going to use this all the time. So you need to understand how to manipulate your units. All right, so I've went ahead and I've written out all these problems. I've just kind of pulled the relevant information out of here. Now, I'm not sure if your professor is actually going to give you the conversion factors. I noticed that when I was finding conversion factors for these problems, he used kind of some of the same units over and over. So I'm sure there's some units that he is going to assume, or he or she is going to assume, that you have memorized. So I'll go over a couple of those. All right, so this first one says, what is the mass in kilograms of an individual who weighs 197 pounds? All right, so remember, anytime you're working one of these problems, the first thing is to kind of pull the important information out of the problem, because these particular problems here are really difficult. They're worded really strange, so pulling out the right information is difficult. But, anyway, that's the first thing you do, is pull out your relevant information. The second thing you do is write down what's given. I was given 197 pounds. Okay, so I wrote down what's given. The next thing to do is to set up your ratio. Now, I have the conversion factor that goes straight from pounds to kilograms. So I don't have to do a multi-step dimensional problem or dimensional analysis problem. I can do it in one step, because I know that 2.2 pounds is equal to 1 kilogram. That's kind of one that's well known. I didn't particularly know that one, but because you'll be dealing with patients that are, they weigh in pounds, and you're going to have to go to kilograms quite often, this is just a conversion factor that you're going to have to memorize. So this one, memorize that one. You're going to need that one. All right, so the first thing we did was we wrote down what's given. Well, the first thing we did was we pulled out information. Second thing we did was wrote down what's given. Now I need to set up my ratio to get my units to cancel. So when you cancel units, let's talk about this in terms of fractions. If you have something like this, the easiest way to do this, because I have a 2 on the top side of a fraction here and the top side of a fraction here, they technically cancel. And so that just gives you 3/1. This is the same kind of idea that we're going to be doing with the units. If you've got 1 on the top side of a fraction and 1 on the bottom side of a fraction, then that means that they cancel. So basically, this is over 1. So that's understood to be over 1. So you know that this 197 pounds is on the top side of a fraction. So that means in order to get pounds to cancel, to get this to cancel, I need to put pounds on the bottom to get it to cancel. So I'm going to put pounds on the bottom. So we're just doing units so far. We're not doing any kind of numbers yet. The numbers will come in just a minute. So I know that I need to get to kilograms. So whatever you're looking for is going to go on the opposite side of where you decided this unit is going. Okay, because sometimes it may be flipped. Maybe you need to have the kilograms on the bottom. Maybe you have the kilograms on the top. It just really depends on the situation. But whatever you decide, where you want this to go to cancel this, your other unit that you're looking for will go on the opposite side. All right, so now that I have gotten my units where they need to go, now I just fill the numbers in from my conversion factor. So I know that 1 kilogram is equal to 2.2 pounds. And so that is just simple in the calculator. So these 2 units will cancel. And I literally, all I have left is kilograms, which is where I wanted it in the first place. So this is just simple in the calculator. 97 divided by 2.2 8.95-ish. Okay, and that's going to be in kilograms because we canceled the other units. So let's see if that's one of the answers. 8.95 kilograms, so that was C. Yeah. And something that you'll kind of notice is that about 2 pounds is worth a kilogram. So if I'm looking at my answer, and if the guy was around 200 pounds, remember the 2 pounds is essentially 1 kilogram, then, well, it should be around 89.5. Did I just read it wrong? 197 divided by 2.2. Okay. Anyway, that's what the calculator says. We're going to go with. I feel like that conversion factor is not correct. Let me go back to Google. This is what it says. 1 kilogram equal to 2.2 pounds. Let me type this in again. How many kilograms? Nope. How many pounds are in a kilogram? .2. Okay. So my brain is having a hard time today. I'm checking myself here. So if we said that the guy weighed 8.95 kilograms and the conversion factor is 2.2, see, that's not correct. We did 197. Oh, that's why. It's putting in scientific notation. How ridiculous is that? Hold on. Normal. Okay. Try this again. What was that? I forgot it already. 190 something. 7. There we go. Oh, okay. Stupid calculator. So 89.5. 5. Nope. Wrong one. Stop it. Okay. Okay, so this actually makes more sense. This is why I was so confused, because I trusted my calculator a little too much. So, what happened was, the exponent was on there, so that's why I missed the decimal place there. But what happened is this is essentially, and this is a good skill to know anyway, this is essentially 200 pounds. And so you know that basically 1 kilogram is 2 pounds. So it's good. I already have, when I do problems like this, I try to already have kind of an estimate of what it's going to be in my head. Sometimes it's just too complicated to figure that out. But this problem is pretty simple. So if you've got 200 pounds and you know that 2 pounds is equal to 1 kilogram, that should be about 100 pounds. Excuse me, not 100 pounds, 100 kilograms, roundabout. And that's better. And we got close because we did say 8.9. 8.96 or whatever it was. That's not even close to 100, so I knew I was wrong. But anyway, so that's good to do just so that you know what your answer should be around. So that's kind of a good skill or a good habit to make, is to kind of guess a little bit. It's okay if you round, because then you'll get you'll at least get close. But then you do the real work, and then there's your answer that you actually put on the test. All right, so let's work on the second one. The second one says the recommended dietary allowance of calcium for teenage children is 1,300 milligrams per day. If a typical 8 fluid ounce glass is reduced fat milk contains 298 milligrams of calcium. Oh, excuse me. How many fluid ounces of milk does a teenager need to drink to get the entire recommended amount of calcium from this milk. Okay, so again, this is one of those problems where your professor keeps using the same units over and over. So there's probably a couple of conversion factors that you need to memorize. Now, whether or not I'm going to use them in these problems is another story. But okay, so I know that, and I just know this, 8 fluid ounces is equal to 1 cup. Okay, I know there's like, he keeps using cups on all of these questions. There's like 2 other questions that have cups in it. Cups is not mentioned in this question, but it's just another one to know. Oh, excuse me. Okay, so that's one I know. I know that 1 quart is 4 cups. Oh, I know what I wanted to say. 1 fluid ounce is equal to about 30 mils. That's about. It's like 29.56 or something like that, but we're just gonna say 30. Okay. So anyway, those are a couple of ones that are really good to know. So I'm gonna erase those. This is the only one we're really probably gonna use is this one anyway, but I'll rewrite it in just a second. So, all right. Again, first thing you do is pull out your relevant information. We said we needed 1,300 milligrams per day. 8 fluid ounces contains 298 milligrams. How many fluid ounces to get to 1,300 milligrams? Okay, so, excuse me. I'm trying to figure out the best way to set this up because there's like 3 or 4 different ways you could do this. I mean, you could do it step by step, or you could do it just in one go with multiple conversion factors. I'm just going to do this the way that makes the most logical sense to me. It may not be dimensional analysis, but I'm going to do it the best way that makes sense. Okay. So if I need 1,300 milligrams per day and 8 fluid ounces contains 298 milligrams, then I need to figure out how many times 298 goes into 1,300. Okay, let me see if I could, I'm going to try to see if I can set this up. I want to say this is the way you would set this up. I want to say this is correct. 1,300 milligrams per day. We're going to try it because I may be very wrong. We will see. Again, these are not problems that I normally do. These are very specific to the nursing field. But the concept is essentially the same. These are just a lot harder than what I actually teach. So we will see if I get this correct. So if I have 1,300 milligrams per day, and I know that there are 298 milligrams in an 8 fluid ounce. Okay, now notice how I set this up. I said, because the goal is 1,300 milligrams per day. So I said this right here, I put that in a fraction, milligrams per day. So now I've got milligrams on the top here, milligrams on the bottom here. That I did that on purpose so that milligrams will actually go away. So these are going to cancel, milligrams cancel, and right now I'm left with fluid ounces per day. Okay, that's literally what's left is fluid ounces per day. And that's kind of what we're getting. We'll see. Fluid ounces, and this is how many we need in a day. So we're kind of getting there. We'll see. All right, let's do some math here. Now, what's a little funky is that, you know, on this problem we had this 1 on top. And I'll have that over here. So what happens when you have that? Here's what you do. You do 1,300 times 8 divided by 298. And this is exactly how you put it in your calculator. 1,300 times, oh crap, I forgot what it was. 8 divided by something. 8 divided by 298. and hit enter. 34.90. I am not doing any of this to significant figures because nobody has time for that. Okay, let's go see if that's an answer choice. Oh, what did I say? 34. Okay, so we've got 35 fluid ounces. Oh, I think that answer is correct because that's what you have to have. Look at me, I did it. Okay. Oh crap, what did I just do? Okay. Oh, fluid ounces per day. All right, look at me, I figured it out. Okay, moving on. Number 3. I have an 185-pound patient. They got prescribed some kind of cholesterol medication, 145 milligrams. They want to know what the dosage is in milligrams per kilograms. Okay, again, you've got to take your patient's weight and turn it into kilograms because when you do dosing, everything is always milligrams per kilograms, almost always. So you've got to get used to converting between pounds and kilograms. You're going to use it all the dang time. So 2.2 pounds is equal to 1 kilogram. Okay, we talked about that earlier. All right, let's set this up. So you write down what's given. I need to go ahead and convert this pounds into kilograms. So pounds goes here, kilograms on top. 1 kilogram is over 2.2 pounds. Mark out pounds. You do 185 divided by 2.2. $84.09. Now, really, when you're dealing with a patient, you're probably not necessarily going to want to round, to be completely honest with you, because you need your dosage to be on point. But I'm just, out of habit, I rounded it 2 decimal places, but it's not always a good thing. Okay. So we figured out how many pounds. So all we've got to do now is just figure out milligrams per kilograms. So that literally is putting the 145 milligrams divided by 84.09 kilograms. I'm sure there is probably a better way to do that as far as dimensional analysis than putting it all in one go and putting all the conversion factors back to back to back to back. But look, don't do it. Just this is logical. I literally put the milligrams over the kilograms, milligrams over kilograms, and that's what it wants. So I don't see the problem there. Okay, so 145 divided by 84.09. 1.72. Oh, that is laser pointer. Hold on. 0.72 milligrams per kilograms. Okay. Let's go see if I got this correct. That is correct. Good job. Okay. All right. That's correct. Look at me. I'm so proud. All right. Next one, number 4. Urine sample density is 1.02 grams per milliliter. They excreted 1,250 milliliters. What mass was excreted? Goodness, I can't write. Okay, anyway. So, really, this is just a density problem. So normally when I teach density, like in physical science, I'll write something like this. I love density. This will help you remember the formula. Well, to be 100% truthful with you, I actually don't love density. Okay, so if you notice that if this line here is a fraction, this looks like an M. This looks like a V. The formula for density is mass divided by volume. So this literally is this is a triangle equation because you have 3 variables. So, excuse me. Ooh, I need to take a nap. Okay. Like this. All right, so what you do when you've got a triangle one like this, I knew that mass was at the top up here because it's on the top side of a fraction here. So when you have this, formula triangle like this, if you've got something that's across this way, like this, like you're trying to find density, what you do is you take your finger and you cover up density, and then you see what's left, and these are over each other, so that means density is equal to mass times, no, not, this is not, mass divided by velocity. But let's say that you wanted mass. So you would cover up mass with your finger and you would see D times V, because these, when they're next to each other, you multiply them. All right. So it wants to know mass. This is what mass. So I'm going to rewrite the formula for mass is equal to distance, no, not distance, density times volume. Okay. Density times volume. Excuse me. Whew. Okay, so I want to know the mass. My density is 0.2 grams per milliliter. And then I have my volume as 1250 milliliters. Now, here's the problem. You will get professors that on homework or classwork or whatever will give you beautiful, beautiful, beautiful units like this where they match. But on the test, they will give you something like this may be in liters, or it may be in quarts, or something crazy like that, because they will do stuff like that. Make sure that when you get ready to put things in a formula like this, that your units match, that they go along with each other. And they do, because here's milliliters and here's milliliters. This is in grams. I mean, if we're talking about doing mass in terms of correct, SI units, then it needs to be in kilograms. But we'll see what the answer choices are. I'm so sorry. Okay. So this is just as simple as going, trying to hurry up and get this done before my iPad dies. 1.02 times 1250. 1.02 times 1250. We get 1275. And that is grams. Okay, so let's talk about units for just a second. So when I did this, I want to look at my units. So my units for density are grams per milliliter. And I multiplied by the volume, and my volume was milliliters. Now, this is how, if you ever forget the density formula, or really any formula that you've got to plug something in, if you will manipulate your units, you don't even have to know the formula, all right? So if you look at it like this, when you multiplied these, this is technically over 1, you canceled milliliters, and you're just left with grams over 1, which is exactly what I needed. Now, I want to go back and look at the question real quick. Let's see if the answer is quick. We said 1275. So we've got, now here's the problem. This answer here is correct, but this answer here is also correct. So I'm assuming the reason why this one is the answer that was the correct answer is because it's in kilograms, which is the correct, not scientific, or significant figure. Nope, still not the right SI. Standard international units. There we go. It's still the correct SI unit, because that is the SI unit for mass, is in kilograms. So sounds like this professor wants you to keep those in mind. All right, moving on before my iPad dies. Number 5, let's do this quickly. Balloon has a volume of 12.6 cups. What is it in liters? Okay, so here's another one of these that I left over here. Now, I had to Google this because I had to Google both of them, to be honest. But this one I didn't know. This one was cups, straight from cups to liters. But this is probably what your professor is wanting to get at. So 21.6 cups. I know that 1 cup is 8 fluid ounces. Cancel cups. 1 fluid ounce is 30 mils. And 1,000 mils is 1 liter. Now, everything is going to cancel with the exception of liters. Now, how you're going to put this in the calculator, 21.6 times 8, hit enter. Take that number, multiply it by 30. Take that number, divide it by, take that number, divide it by 1,000. Now, remember that I taught you, if it's on the top side of a fraction, you multiply. If it's on the bottom, if this is on the top side, you multiply. If it's on the bottom, you divide. Okay, they're all over 1. Now, like we did with this one here, oh, not that one, this one here, this didn't have a 1 on it, so you had to do it in parentheses and do the whole thing. But because you've got ones are useless, they don't do anything. Don't put them in your calculator, you're wasting your time. All right, so we're going to do, now you could do this all in one go in your calculator, but this sometimes if you don't put the parentheses in the right place, it will not come out the correct answer. So 21.6 times 8, enter, times 30. And you notice I'm not rounding as I'm doing this. Divided by 1,000. Oh, no. Stop it. Nope, still didn't. Enter. Okay, 5.184. And the unit is liters. Let's see if that is the correct answer. 5.184. Okay, so, oh, it looks like they're doing answers as significant figures here. Okay. So technically you're multiplying on all of this, so that means you need to use the entire number. We're going to do significant figures. There are 3 significant figures in this answer, which means you need 3 significant figures here. So this is not correct. Now, this is the only ones that are close. I did not round when I did any of this. Okay, your professor may have round. Your professor may have actually used this. I don't really know. And they may not have used 4.227. They may have done 4.23, which means that their answer is going to be off a little bit. But this is the closest answer. That's the one we're going to go with. All right, number 6. Moving on. Please don't die, iPad. Please don't die. Okay. 85.32 milliliters of blood. The density is, okay, so this is just like number 4, I think. So we know that density is equal to mass divided by mass. Oh, goodness, mass divided by volume. Mass is equal to density times volume. So our volume is 85.32 milliliters. Now we're checking to make sure that this matches. It does, so we don't have to change anything. So mass is equal to the density of 1.03 times 85.32. Oh my goodness gracious. What do we say? 1.03 times 10, no, 1.03 times 85.32. 1.03 times 85.32. 87.88 is what I'm going to go with. And this is going to be grams, but remember that your answer probably should be in kilograms. Let's see what answer choices we've got. Oh, it gave you everything in grams. Oh, look how nice that was. So yeah, C, that's the closest one. Okay, last one. iPad, stay with me. Okay, honey has a density of 1.36 grams per milliliter. So there's your density. You have a volume of 1.25 quarts. Okay, this one is particularly messy. All right, now, like I said before, you've got to make sure that your units match. Well, on this one, they don't. Also, this doesn't match either. So yeah, this one's going to take a little bit. So 1.3, we're going to start with this. No, let's not start with that. Let's take care of this volume nonsense. To even use the density, my volume needs to be in milliliters. It's got to match in order for this to work. I think my app just crashed. Let's see. Yeah, the app crashed. Okay. So 1.25 quarts. These are ones that are kind of common knowledge. So I know that 4 cups Nope, backwards. I did it backwards. Got to cancel units. I know that 1 quart, still did it backwards. 1 quart, there we go. Now I cancel units. 4 cups. Next step up, down. We're going down, small units, small units. Quart's a big unit, we're going to small. So I know that 1 cup is 8 fluid ounces. Cups cancel, times, I know that 1 fluid ounce is 30 mils. Okay, so you do 1.25 times 4 times 8 times 30. 1.25 times 4 times 8 times 30. Because you're multiplying, you just do it across the top. All right, so that's 1,200 milliliters. Now, we can go ahead and multiply that by the density because, again, we're looking for the mass. Mass is equal to density times volume. So that's going to be density, it's 1.36 grams per milliliter times 1,200 mils. Mils cancel. So 1.36 times 1,200, 1632 grams. Now, to do actual dimensional analysis, to get from grams to kilograms, 1632 grams. Grams go on the bottom. I know that 1,000 grams is the same thing as 1 kilogram. So I'm going to divide 1.632 kilograms. Let's go check the answer. 1.6, what was it? 1.632 kilograms. So it looks like these answers that they're giving you actually is the correct number of significant figures. So it's D. All right. Okay, so, iPad. Hope this helps. Text me back if you need some more help. I don't mind.